Okay, so let's see if we can answer the questions together. Here's my Wireshark capture. I've filtered for BGP. And the first question is, which autonomous system numbers are the routers configured in? So let's start with router 1. Here's router 1. This is an open message from router 1. I know that's router 1 because router 1 has this IP address, 15.1.1.1. So opening up the BGP message, we can see BGP identifier as an example. We can also see the autonomous system number right there, so 65,001. So 65,001. Bunch of messages between router 1 and router 4. Here's router 2. Notice autonomous system number is 65,002. Here's router 4. That's a keep alive. Here's an open message. Autonomous system number is 65,004. Now, when you filter in Wireshark, you can type BGP dot or period and then look at various options. So as an example, let's look at open identifier. That shows us all the open messages. So we're only seeing open messages at the moment. We're not seeing keep alives. So use Wireshark filters to help you find information more quickly. There's the autonomous system number of router 3, 65,003. What are the BGP router IDs? Well, here's the one for router 3, 3.3.3. Router 1 is that. Router 2 is this. And there's router 4, 17.777. So that's router 4's router ID. Okay, so we've answered those questions. Next question is, which devices have BGP relationships with each other? Now, what you can do with Wireshark is once again type BGP dot and then look at some of the options available. So as an example, I'm going to say BGP update path attribute. That will allow me to see which BGP routers are sending updates to one another. So as an example, router 4 is sending an update message to router 1. It's sending network layer reachability information such as this. So we can actually see the routes that are being advertised from router 4 to router 1. So that actually allows us to answer another question. Question 6. These are networks that are being advertised by router 4. So I can quickly add them here. What's interesting to see here is that there's a network 4.4.4.4/32, which looks like a loopback, but the router has a different router ID. It's using this as its router ID. So let's have a look at that just on the router to confirm it. So on the router, show IP BGP. We can see that this router, router 4, has this router ID, which is what we saw in the Wireshark captures. Show IP interface brief. Now the reason for that is here's a loopback, which I would have assumed would be the loopback of the router per the other routers. But it has this loopback, which has a higher IP address. So this became the router ID for router 4 rather than 4.4.4.4, unlike the other routers. So Wireshark has shown us that quite clearly. Really nice information available in Wireshark. But let's go back to this question. Which devices have BGP relationships with each other? I would say router 1 and router 4, because router 4 is updating router 1 with information. BGP routers will not exchange route information with one another until a relationship has been formed. Here's router 2 talking to router 1, and you can see the routes being advertised to router 1 from router 2. So again, this IP address 15.1.1.2 is sending an update to 15.1.1.1. So router 2 is telling router 1 about these two networks, which are connected to router 2. We can confirm that once again by looking at the console of the router, show IP BGP. Notice there's the router ID. Here is the routing table, show IP interface brief. Notice there's a loopback interface, and there's the gigabit interface that's used to connect all the routers together across this switch. So again, Wireshark is showing us clearly what's going on. So I'll do it this way. Router 1 has a relationship to router 2. What about router 1, router 3? I mean, there again, you've got router 1 talking to router 2 and showing the networks that router 1 has. Router 1 is talking to router 3 and router 4. So based on what I see here, router 1 is talking to router 2, it's talking to router 3, and it's talking to router 4. So I would say router 1 has a relationship with those, and I'll just put them in order, those 3 routers. Does router 4 talk to anyone but router 1? We don't see any update messages from router 4 to anyone but router 1. And I mean, what we could do here is we could do something like this. So say search for BGP and IP source equals 15.1.1.4. And notice all the messages are going from router 4 to router 1. Let's look at router 2. All the messages are sent from router 2 to router 1. What about router 3? All the messages are sent from router 3 to router 1. So there are no relationships between router 4, router 3, and router 2. All the relationships are to router 1. And we can confirm that by typing show IP BGP summary. Let's say on router 2, you can see it has a relationship to router 1. On router 3, let's have a look at the BGP table. Show IP BGP summary. Relationship is to router 1, no one else. And let's have a look at router 4. Show IP BGP summary. Relationship is once again to router 1. So that confirms that none of the routers have relationships with each other. They only have relationships with router 1. On router 1, show IP BGP summary. It has a relationship with router 2, router 3, and router 4. Now, the reason this works is that router 1 is in a different autonomous system number to router 2, router 3, and router 4. So it'll learn a route, let's say, from router 2, and then it will advertise that to router 4. So going back to our questions, we have this question here. What is the AS path for router 4 to get to this network? So back in Wireshark, when router 1 advertises a network to router 4. So let's have a look at this message. Router 1 is sending a BGP update to router 4. Notice this network, 3.3.3.3. That is a network associated with router 3. Path attributes, notice AS path, 65,001, 65,003. So what is the AS path for router 4 to get to that network? It would go via 65,001, and then it would go to 65,003. Now the next hop is actually set to 15.1.1.3, and that's because these routers are on the same subnet. So router 4 will not send traffic to router 1 when going to router 3. Because they are in the same subnet, even though he learnt about 3.3.3.3 from router 1, the next hop is set directly to router 3. So the network here, which is a loopback on router 3, is advertised to router 1, then to router 4, but router 4 will send the traffic directly to router 3. Hence, next hop 15.1.1.3, even though the AS path is set to this. And notice this origin, IGP, path attribute. The origin of the route was IGP, which means that the network statement was used. The network statement is how you get a route into BGP and it's shown with this origin, IGP. So on router 4, show IP BGP, notice this network here has this origin, IGP. So notice the I over there. This is an external network. It's not internal. So the I is not shown on the left-hand side. But the route was learnt through IGP, which means network command. Back on router 3, let's prove that show run section BGP. We can see that that is true. Notice network command. Wireshark is showing us all this information. Remember, Wireshark is just showing us what the routers advertise to one another. So whatever they advertise to one another, we can see through the Wireshark capture here. So we can see the AS path attribute, we can see the next hop attribute, we can see flags, so origin, we can actually see what the network is. Okay, so how did you do? Were you able to answer these questions just by looking at the Wireshark captures? How did you get on? Hopefully, you were able to answer most of the questions.